Right, guys, we're gonna do a review for Miss Meador's first college algebra test. Here we go. On the first 4 questions, it says determine if whether y is the function of x. You're gonna use the vertical line test. So you can use your pencil, use it as a vertical line, drag it from the left to the right. If the graph touches your line in more than one place at any given time, it's not a function. Number 1 is a function because it passes the vertical line test. Number 2, you'll notice is like an oval or an ellipse. It fails the vertical line test because this x has 2 different y's, and there's lots of different x's that have 2 different y's. So number 2 is not a function. Number 3 passes the vertical line test, so that is a function. And number 4 is a sideways parabola. So it fails the vertical line test, so it is not a function. All right, so she'll probably give you like one of those on the test. That should be a gimme question. If you flip to the second page, it says determine whether the relation is a function. And she gives you 4 different problems, and she gives you the problems in different ways. In number 5, she just writes out a set of ordered pairs. Now, what you're looking for on this is the definition of a function is each x can have one and only one y. Each x, each girl, can have one and only one y, one guy. So in the first example, I'm looking for any x's that repeat. Got a -2, a 1, a 5, a 7, 11. None of the x's repeat, so we should have a function. So we'll say yes, function on number 5. Let me check this real quick. Okay. On number 6, every x, 3, 8, 3, oh, you have 2 x's that are the same. Your girl 3 is seeing 13, your girl 3 is seeing 10, that is not a function. On number 7, this x, -6, is seeing 2 different y's. A girl cannot be seeing 2 different guys, that's not functional. So no, not a function. And on number 8, you have a -6, a -2, a +2, a 7. All the x's are different, so it is a function. It would also pass the vertical line test if you were to graph any of those. Pretty easy section as well. Jump down numbers 9 through 12. On numbers 9 through 12, it asks for the domain and the range. Number 9 is pretty easy. Domain are all the x's. Range are all the y's. So you're just going to list all the x's once for domain, list all the y's once for range. You're not repeating the x's or any y's. List them in set notation like she does on the answer sheet. I'm not going to waste time going over that. Number 10 is a line. A line goes left forever, right forever. So if you were to graph it on your graphing calculator and you looked at domain, domain is x. X is going to go left forever, right forever, so -infinity to infinity. Range is going to go up and down forever, so that's -infinity to infinity. Now when you get to number 11 is a square root function. If you were to graph that, it's going to look, this is number 11, it's going to look a little something. You think it would go right 3, but it actually goes left 3. And it's doing a little something like this. So if you're looking at domain, remember domain goes left to right. It only goes as far left as -3. So you would put a bracket, -3. It goes right forever, that's infinity. Parentheses on infinity every time. That is your domain. Your range are your y values. Y goes up and down. The graph only goes down to 0, so it starts at 0. It goes all the way up. I know it looks like it's leveling out, but it's going up to infinity. If it equals, use a bracket. If it doesn't equal, use infinity. So domain is x, look left to right. Range is y, look up and down. Now, number 12 is not one of our family of functions. So let's talk about number 12 for just a minute. On number 12, it says x equals the absolute value y. That is the exact opposite of y equals the absolute value of x. So instead of a v opening up, it's a v that opens sideways. And the transformations will follow if she gave you something in for her own test. Now it's not a function because it fails the vertical line test, but she didn't ask you that, and then she asked you for domain and range. So domain is x, x goes left and right. It goes to 0 is where it starts on the left, and it goes right forever infinity. the range of the y values. Y goes down, y goes up, it goes down forever, goes up forever, negative infinity to infinity. And so that's domain of range. If you're given ordered pairs, you just list the x's and the y's. If you're given an equation, you can always graph it and look at that on your calculator, look left to right, up and down. Okay, next section is evaluate. Don't hate evaluate. You may use your calculator. You can just plug it in. They're using function notation here, so like on number 13, it says f of x equals negative x minus 7. They want you to find the f of 6. So everywhere there's an x, you're going to plug in 6. So we have the negative of 6, negative of absolute value of 6 minus 7. Inside the bars, you have a negative 1, and the negative of the absolute value of negative 1. You do the bars first, that's 1, and so we have negative 1. If you're struggling with that, making mistakes, you can always use a graphic calculator. Let me see if I can. You can always type it in like you see it. Negative, absolute value, alpha window, and then plug in your 6, and then minus 7. Same answer. Coincidence? I think not. Okay, number 14. If f of x equals this, she gives you a quadratic. Everywhere there's x, we're going to plug in negative 3. So for time, I'm just going to put a parentheses here, parentheses there, and plug in negative 3. So on the calculator, we have negative 4, parentheses, negative 3, squared, plus 5, parentheses, negative 3, close parentheses, minus 2. Double check it, especially on the test. You don't want to make any silly mistakes. Plug in a negative 3 for x, plug in a negative 3 for x. You're evaluating, so you get a number, negative 53. So that is the answer to number 14, negative 53. Now, number 5, you might actually have to do a little algebra here. It says find the g of a minus 1, and it gives you a rule for g of something. So the rule for g of something is 5 times something plus 4. But instead of x, we're going to plug in the something, a minus 1. I'm going to use a capital A. Distribute, you have 5 times a, which is 5a. 5 times negative 1, negative 5. Written down to plus 4. Combine like terms. The only like terms are negative 5 plus 4. So you get a negative 1, so 5a minus 1. So everywhere there was x, plug in a minus 1, distribute, simplify. Okay, jump back to 16, it's find the f of negative 4. So you're just going to plug in negative 4 in where the x is. I would use my calculator, don't take chances on making mistakes, but if you use a calculator, make sure everywhere there's an x, you put parentheses. So on the calculator, put that back up here. We have parentheses, okay? And then where x is, we're going to do parentheses, negative 4, close parentheses, minus 6, close parentheses, squared. And you get it at 100, exactly 100. Okay, now, hopefully you're feeling confident through this point. Next we get to word problems. I know people don't like word problems, guys. Most of the time word problems, remember, the math is easier. You just have to figure out what they're asking. So it says, suppose the sales of a particular brand of appliance satisfy the relationship, S of x equals 210 times x plus 2300, where S of x represents the number of sales in year x. Okay, so S of x is the number of sales, the year is x, and it says with x equals 0, corresponding to 1982. So 1982 would be year 0, all right? And what year, so they're asking you, what is x? Would the sales be 5870? So in this equation that she gave you, we're looking for x, and we're given the sales. So we do not know x. 210x plus 2300. We know that the sales, though, is 5870, so sales goes over here. Now we just have a two-step algebra 1 equation where we're going to solve for x. So you're going to minus 2300 minus 2300. We have 210x, those cancel. 5870 minus 2300. You get 3570. Then you're going to divide by 210, divide by 210. Let your calculator do the work. And I got 17. Now, you gotta make sure you read the question. Are you gonna say in year 17 is when they added sales? No. You're gonna add 17 to the 1982. So, because it's 17 years after 1982. So when you add 17 to that, you get 1999. Which should be the correct answer. Let's check. Yes, it is. So make sure you read the question, take your time on the word problems. You should have ample time to do this test. Go back and check your work. Can't afford mistakes. Okay, number 18. The mathematical model C equals 500x plus 70,000 represents the cost in dollars a company has in manufacturing X items during a month. How many items were produced if its cost reached $320,000? So X is the items. The question is, how many items? We don't know what X is. How many items were produced if the cost is this, so that's your C. So in your equation, C equals 500x plus 70,000, you're looking for X, you know C. So you plug C in on the left, 320,000, oops, 320, and then we're going to solve for X. And that's a two-step equation, so you're going to minus 70,000, minus 70,000. You're left with 500x, 320,000 minus 70,000. I think that's about 250,000. Probably should use a calculator to check that. And then divide by 500. So we have 320 minus 70,000 and divided by 500. That's common sense with it. So we get X equals 500. Now what was the question? How many items were produced? So 500 items, and that is the answer. Okay. Word problems, those were probably two of these probably done. Okay. Number 19. Number 19 wants you to graph. It says graph the equation by plotting ordered pairs of numbers. Now she gives you an equation that is in no particular form. It's not in y equals mx plus b form. It's not in point slope form. It's not even in standard form. If I were you, I would solve for y, where you could use your calculator tool to make a table of values. So if we're going to get y by itself, we're going to subtract 1 and subtract 1. 2x minus 1, they are not like terms. So you just write it as 2x minus 1 equals y. So on the graphing calculator, let's go to y equals. Hopefully you can see this. I'll come back to the graph. Clear out anything that's on your calculator. We're going to graph y equals 2x minus 1. Now remember to zoom standard the first time you graph something. Okay, so we have a line. Look, you can't just throw a line on your piece of paper for the test. You need specific points. She said graph the equation by plotting ordered pairs. Well, that's where you use the table from your calculator. Now, don't just go to second table. You want to set your table. So I'm going to go to second window, which is table set. And table start of -2 actually is good. We want to change a 1. Auto and auto should be selected. So that's how we're going to set our table. And then we're going to look at our table with second graph, which is second table. Now, on the test, you've got this. So I would copy, I would say anywhere from 3 to 5 points. The more the better on your paper for your test to get full credit. So X, we have this. Y, we have this. We have -2, -5, -1, -3, 0, 1. I'm sorry, 0, -1, 1, 1, and 2, 3. And then you're going to plot those 5 points. She may have told you in class how many she wanted. -2, -5, to make sure you plot right. That's left 2, down 5. Don't make any careless mistakes. -1, -3 is left 1, down 3. 0, -1, 1, 1, and 2, 3. And they should all fall on the line. So this is showing where you solve here is good, showing the table is good, and then you plot the points, connect the dots. Make sure you put arrows on the ends of the lines and connect your dots. No room for careless mistakes. Okay, that should be a gimme question. Actually, the next couple should be gimme questions because you can use a graphing calculator. We're gonna do the same thing. So now look on number 20. The parent function is gonna be radical x, but if you graph this on the calculator, you'll notice that there's been a reflection and a translation. So let's graph that. We have negative square root of 3 minus x, zoom 6, zoom standard. I don't know if you can see that. Okay, so the domain goes left forever, it only goes to positive 3 with a bracket. If we did range, it goes to negative infinity up to 0. Okay, that's review of other stuff. She wants you to plot points. Okay, so I would pick maybe a couple of negative ones and go all the way up to 3. If you go back to the table you just used, you'll notice that to the right of 3 you have arrows because there's no graph there. Okay, and I'm going to pick some nice numbers. So I'm going to pick 3, 0. So I'll just use the table of values on my paper, on my test. And I'm going to pick 3, 0, 2, negative 1. I'm going to use negative 1, negative 2. And maybe arrow up and use another nice number because we don't want to have to graph decimals. So the next nice number is negative 6, negative 3. And hopefully that should be enough to get you full credit. 1, 2, 3, 0, 2, negative 1, negative 1, negative 2, negative 6, negative 1, 2, 3. And your graph is doing a little something, something like that. Now that's where the graph ends, but it goes left forever, so make sure you put an arrow on the left part of that graph. Okay, easy points. Now number 21 is going to be an absolute value. So the only trick here is knowing where the absolute value button is on the calculator and its alpha window. You should know that it's going to be a V shape because it comes from the absolute value family of functions. And so I'm going to go to y equals and I'm going to graph that alpha window. Number 1, negative 2, make sure you type in a negative on minus, and then minus x, zoom 6. So there's your V, it's been shifted left 2 units. You need a table of values. Now I will tell you this, if I was teaching, I would want where that V was to be in the middle of my graph. That was at negative 2. So I want this point to be in the middle of my table. So negative 2, 0, I'd have in the middle. And I'd pick these other points. So I'm going to start at negative 4, 2. I'm just getting this off the calculator, second table. Negative 3, 1, negative 2, 0, negative 1, 1. And I bet this is going to be 0, 2. You can just arrow down. And if I'm talking too fast, I apologize. Trying to get through this quickly. You can always pause, rewind, whatever. So negative 4, positive 2. Negative 3, positive 1, negative 2, 0, negative 1, 1, 0, 2. Connect your dots, put arrows on the ends because it keeps going left to right forever. Okay, those were easy. She'll probably just give you one of those. I'm assuming it won't be a line. Most likely it'll be a square root or an absolute value. Now, number 22 is called a piecewise function. You can do this with a calculator, you can do this without a calculator. Got to remember how to type it in the calculator. This is considered to be the domain. Okay, now, so I got a feeling a lot of people will be asking questions about this. So to type this in the calculator, in your y1, you're going to type the function in parentheses. On the first function is just the constant function, y equals 2. And this is the domain. So you put the function in parentheses, you hit the domain, or put the domain in parentheses. In your second y, your y2, you're going to put this function, which is a linear function because it's x to the first. You're going to put that in parentheses, negative 4 minus x. You're going to put the domain in parentheses. Okay? And then you're going to go to zoom standard like we always do. Now, most people don't know how to get the greater than, less than. You're going to go to second math, which is the test menu. Second math, which is the test menu. All right, good. You can see it all. All right, so y1, I'm doing parentheses 2, close parentheses, x, use your x key. Greater than equal to 1. Second math, which is test, greater than equal to 1, close parentheses. So what that is going to do is that's going to graph the constant equation, y equals 2, which is a horizontal line, from 1 or greater than 1. So technically, it's going to be equal to 1, and it's going to go greater than 1. Now, when x is less than 1, we're going to use the line, the linear function. So parentheses, -4 minus x, close parentheses, open parentheses. X is less than, second math, which is test, less than is 5, 1. And we're going to zoom 6. Okay, so now, this was what I had already drawn, and that's a closed circle that she's going to be paying close attention to that on the test. Why do we do a closed circle there? Because it's equal to. Now, what we got to figure out is, at 1, where's that last dot for that? Well, plug 1 into this equation. If I plugged a 1 in, it'd be -4 minus 1, which would be -5. So 1, -5 is where the line is going to stop, but that's going to be the open circle. Okay, now, if you want other points, you could plug in other points. Like you could put in 0. -4 minus 0 is -4. That'd be right here. If you plug in -1, -4 minus -1 is -4 plus 1, that's -3. Okay? You could keep doing that, or you could use your table of values again. Okay? This is your y1. Okay? When x is less than 1, it's not using that, so it defaults to 0. Okay? So we're using our y2. So at x equals 0, -4, that's the point I just grabbed. When x was -1, -3, -1, -3. When x is -2, we have -2. Left 2, down 2. So it has a slope of -1, that's why it's going down 1, right 1. So it goes like that. This is open because on the second equation, there's not an equal to. The first equation to the constant function has the equal to. This is still a function because it passes the vertical line test. So open, close, we're using the linear function, the second function here, we're using the constant function, the first function there. Okay? You might want to replay this if you're struggling with it. All right, number 23 says determine the intervals on which the function is increasing, decreasing, constant. Increasing, decreasing, and constant. Well, this function is an absolute value function. So you read left to right. So from -infinity, as you come along, the graph is increasing. Until you get to this x value, you want to look left to right. So right here, this x value, -1, 2, 3, 4. At -4, the graph changes from increasing to decreasing. Okay, we're not looking at y values, we're looking at x. So from -infinity to -4, the function's increasing. -infinity to -4. Now let me see if she wants you to put a bracket. She wants you to use a bracket on -4. Okay, so it gets up there, it touches. There's some mathematicians that would say, oh, parentheses, because technically at -4 it's neither increasing or decreasing because it's 0 there. That's a calculus thing. Okay, so it's increasing from -infinity to -4, and then from -4 forever to the right, it's going to decrease. So decreasing from -4 to infinity. If she wants a bracket, use a bracket, it's all good. Okay, number 24. Now, I'm only going to, 24 through 27, she wants you to graph the parent function and a related function. So like, on number 24, she has x squared, and then she has x squared minus 4. Guys, y'all can do that without a calculator. That's just shifted down 4, but you need to read what she tells you to do, okay? Use the dash line for g of x. So, the mother function, watch your mouth, f of x equals x squared, she wants you to draw in normal. Now, don't just sketch it. That's garbage. Okay, use your calculator if you need to plot some points. Okay? And then we're going to do x squared minus 4. If you want to do them on the same calculator on the same graph, that's fine. So, can't see that. Hopefully it's a little better. So let's clear out whatever was in there. I'm going to do the mother function, the parent function first, and then x squared minus 4. You should know that that's going to shift it down 4. Zoom 6. So here's the parent function. and then we have down 4. You're going to dash g of x, the second one. Make sure you read that on the test. Okay? But I need some specific points. So I'm going to use my table. Before I go to table, I'm going to set it up. I'm going to go to second window. I'm going to start at -2 with a change of 1. Second graph. Now this is where you got to be careful. This is your first y. This is your f equation, your parent function. So -2, 4. Left 2 up 4. -1, 1, 0, 0, 1, 1, 2, 4. She wants you to connect that with a solid line. And you probably make sure you got arrows on the ends, make sure you label that f of x, okay? No hate, no take. Your second equation was your g of x, it was the one shifted down for. So -2, 0 is a point. -1, -3 is a point. 0, -4 is a point. 1, -3 is a point. And 2, 0 is a point. Every dot has just been shifted down for. Try to curve it, don't make it a V. Put arrows on the ends and label that g of x. And there you go. You're going to do the same thing with the absolute value. You're going to use alpha window number 1 for absolute value. You do the same thing on 26 is another absolute value. And 27 is another parabola. I will tell you this, when you're doing a parabola that has been shifted left or right, just real quick, trying to hustle here, because all these can be done in the calculator. You should know that the new vertex is right 3, down 4. Okay? So you need to do your regular function here, but on your ordered pairs, you need to go around that vertex. So pick that vertex, pick a couple numbers to the right, pick a couple numbers to the left. Make sure you dot the one she tells you to, arrows on the ends, and label, label, label. Okay. 28 is, man, that's cake, okay? She gives you a graph, you gotta match it. You should know that is the parent function, x squared, that's been shifted down 3, that's just x squared minus 3. Doesn't get easier than that. Okay, same on number 29. Absolute value looks like it's been shifted right 1. Now right is x, you think it would be plus 1 with x. Okay, but remember with x you do the opposite, so it's minus 1. Okay, it looks like D might be a choice, but D also has a horizontal and a vertical translation. So it's moved right 1, you think it'd be plus 1, but it's minus 1 with x. Guys, all you gotta do is graph each answer to see which one matches. Nobody should miss that question. Same thing on 30, match the graph. There's been a reflection, just graphing the answers until you find one that matches if you want to. Now, it looks like on 31, it says use transformations to graph the function, state the domain range. You're gonna graph it in the calculator, plot points like we've been doing. Now, she doesn't want you to graph the parent and that, she just wants you to graph that. So I'm not gonna do it with the calculator to save time. It's right 6, down 7, right 6, down 1, 2, 7, and it's a V shape. And if you want to get specific points, use your table, and I would do that on the test. She wants domain and range. Domain is x, it goes left forever, it goes right forever. Domain is -infinity to infinity. I'm not sure she wants braces. Let me just check that real quick. Some people get a little OCD. Yeah, she's not good. So she wants you to go -infinity to infinity, and then your range. It does not go down forever. It only goes from -7, goes up forever, positive. Domain is x, think left to right. Range is y, think bottom to top. Okay, pretty easy section. Don't worry, it'll get more challenging here in a second. Okay, number 32. The graph of the given function is drawn with a solid line. The graph of the function g of x transformed from this one is drawn with a dashed line. Find the formula for g of x. Okay, this is not bad at all. So you need to know the parent function that she gives it to you, f of x. Absolute value of x. Well, all she did was translate it right 6. Now, right 6 wouldn't hurt you to probably write that on your paper when you take the test. Left and right is x. So inside with x, you're going to do something with 6. Most people think it's plus 6, but remember with x, It's the opposite. So your g of x function, make sure you label it g of x, your new function, is x minus 6. If you want to check your work, graph that on the calculator, make sure it went right 6. No reason to miss that. That is 32. Okay, just 40 left. Yay. That's called sarcasm. Same on number 33. Parent function is x squared. Looks like we went right 6, down 6. So inside with x, you have to do parentheses. Right, you think would be plus, but it's minus because it's with x. Down 6 is what it says because it's y. Make sure you label it g of x because that's your new function. If you want to write right 6, down 6 on your paper, it might help partial print in case you make a silly mistake. 34. Use transformation to graph the function, set its domain range. Well, obviously you can use a graphing calculator, okay? So why not? I know it's going to go left 2, down, up 1, excuse me, but the negative is a reflection. So the negative is with y. We don't want to be a reflection of someone who's negative. We want to reflect on the positive. So we're going to reflect over the x-axis. So the parent function is this, like this. So if we reflect over x, it's going to up and down. And then we're going left 2, down 1. So it's going to be doing this, left 2, down 1. Let's use a calculator. Don't hate, calculate. So y equals, clear out anything you have in there. Negative square root x plus 2. Go outside the parentheses, plus 1, not parentheses, excuse me, the radical, hit plus 1. Zoom standard. Now be careful. I think I said down 1 while ago. You're going to go left 2, up 1, all right? So that's right here, left 2, up 1. And then it's doing this. If you want to get some points off your table of values, you can. So I'm going to go to table. You'll notice that we have an error if we go past -2 because there's a domain restriction. So -2, 1, we already have that. -1, 0. And then the next nice point is 2, -1. And I think she'd probably be good with that. Put an arrow on this end, not on this end, because that's the starting point. Now it wants domain and range. Domain is x. X goes left, it only goes as far left as -2. It touches there, brackets. It goes right forever. Infinity, you never equal infinity, parentheses. Range are your y values. Y goes down and up and down. It goes down forever, but it does not go up forever. The y's only go up to 1. So on your range, we're going to start at the bottom, negative infinity, go up to 1, brackets on 1, parentheses on infinity. Sorry, negative infinity. Okay, now to a little bit more challenging. We have some function notation. There's going to be more than one way to do these. You could do f plus g of x with variables and then plug in the -3. Or you could do the f of -3, the g of -3, and then add the two together. For some of you, that might be the easiest way. So let's try that way. Let's find the f of -3. You can use a calculator if you need to. -3 minus 4 is -7. You can find the g of -3. Stuff minus 6. -3 minus 6 is -9. And the question wants you to do f plus g of 3. So you're going to take your f, which is -7, plus your g, -9, add it together to get -16. If you don't like that method, you could have added this and this. Okay, you could have done this. Take f of x plus g of x. Combine like terms. Then plugged in the -3. And look what you got. Same answer. Coincidence? I think not. Okay, that's 35. 36 wants you to, for the pair functions, perform the indicated operations. It wants f closed dot means times, f times g. Now, there's no number involved, so this is not a number answer. You're going to be doing stuff with variables. So we're just going to simplify the expression. We want f times g, that's the same thing as f of x times g of x. You're going to put f of x here. You're going to put g of x here. You have a binomial times a binomial. You must use the f word, FOIL. Not sure where some of y'all are going there. All right. Some people like to call that distribute twice. 9 times 6 is 54. X times x is x squared. Really take your time here, don't make little mistakes. 9x times -1 is -9x. It's your first times your first, your outer times your outer. Now you're going to do inner times inner. That's going to be 54x. That's 54x. 9 times -1, -9. If you're looking for like terms, the only like terms are in your middle. 54x squared minus 63x minus 9. And that is your answer. Stuff times stuff, binomial times binomial, you must FOIL. Okay. Number 37. Says find f minus g of f, and they give you f and g again. Now this one has a number. It wants the f minus g of 4. F minus g of 4. So you could plug in 4, and then subtract the 2. I think that's the easiest way to do it. So here, everywhere there's an x, we're going to use parentheses and plug in a 4. Same thing on the g equation. Everywhere there's x, we're going to put parentheses and then plug in a 4. So you can use your calculators. If you don't have a calculator, you're going to do exponents first. 16. 16 times -5, I believe, is -80. -80 plus 5. -75. Over here we have 4 plus 1, which is 5. Now they want you to take f, then minus g. So f minus g, that's -75 minus 5, and that is -80. -80. Function notation. All right, number 38. 38 wants you to find f times g of 5. Again, this is a product because it's a closed circle. It's not an of. That's compositions. We'll do those in a minute, I think. But there's a number mode. So you could just do the f of 5 and then the g of 5 and then multiply the two answers. That is the easiest way to do this. So everywhere there's x, we're going to plug a 5 in. 5 minus 4 is 1. So the f of 5 is 1. Over here, where there's a g, we're going to plug a 1. Nope, just kidding, we're plugging a 5. Oops. Y'all can edit that yourself. Okay, so we have -2. Stuff squared plus 11 times stuff minus 3. Everywhere there's an x, we're plugging in a 5. Don't take a chance on it. Type it on the calculator on your test. You have plenty of time on the college algebra test. 25 times -2 is -50. This is 55. It's 5. 5 minus 3 is 2. I believe we're going to get 2 times 1. Yep, 2 times 1. Because this is f of 5. That's g of 5. They want you to take f times g. So you just do 1 times 2, which is 2. All right. Moving right along. 39, a little bit more complicated, I guess. Not really. It wants you to find f divided by g of -5. There is a number mode. Plug the numbers in first, then divide at the end. That's the easiest way to do these. So we're going to find the f of -5. Everywhere there's an x, you're going to plug -5. You may use a calculator. That's -10 minus 2. That is -12. Over here, we're going to find the g of -5. So everywhere there's an x, we're going to put parentheses. Parentheses are important in the calculator. They're going to type this in the calculator. Yeah, I'm going to use a calculator. Saturday, I'm working too hard anyway. Okay, let's see. 5 parentheses -5 squared. Type it all in, you get 60. Now you need to make sure you RTFQ, read the freaking question. It wants f divided by g, not g divided by f. So make sure you pay attention on the test. F divided by g. So this is negative 12 over 60. It's going to be negative 1/5. Same thing as negative 0.2. Let me see what, yeah, she wrote it as negative 1/5. So that's what I would go with. And that wasn't too bad. Okay, number 40, which is the last in this section. You're given f of x, you're given g of x, and it says find f plus g of x. Now there's no numbers involved. So you're just going to add f of x and g of x. Let me stop for a second. A lot of students try to make this problem harder than what it is. They want to add f and g, then multiply by x. That does not mean times x, it means f of x. F plus g of x means f of x plus g of x. Stuff plus stuff. Parentheses plus parentheses. So first stuff is 4x minus 3. Second stuff, negative 8x plus 8. Combine your like terms. 4 minus 8 is going to be negative 4x. Combine like terms, negative 3 plus 8, positive 5, and there you go. You're given, it says for f of x equals blah, g of x equals blah. What is the domain? Domain are x values. What is the domain of f plus g? So you're supposed to add them together and talk about domain. So that means f of x plus g of x. Oops, 2x minus 5 is f of x. Square root of x plus 5 is that. If you were to combine those two, there are no like terms. Now you could graph this on your calculator. Let's look at it. I'm pretty sure it's going to be domains greater than or equal to -5 because it's the same restriction on the radical, but let's check. Let's graph 2x minus 5 plus, that's your f of x, let's add g of x to it. Square root of x plus 5. Zoom 6. Now this looks like a straight line. You really can't tell, you gotta know what's going on. If you zoom out, it's gonna look like this. That was helpful. Okay? It goes right forever, but it doesn't go left forever. So I'm gonna go back to zoom standard for a sec. Zoom 6. Now, there's 3 things you can't do in math. You can't divide by 0. We don't have division in this problem. You cannot take the square root of a negative number. We do have that in this problem. So right here, x plus 5 can't be negative. So x plus 5 has to be greater than or equal to 0. Because if it's 0 or greater, it's positive, it's not negative. So if you subtract 5, that tells you that x needs to be greater than or equal to -5. Another way you could do this is by looking at a table of values. You should know something's going on at -5 because that's where it's been shifted. Square root of x has been shifted left 5. Then it's been added onto this line. So if I go to table of values, everything's looking good to the right of -5. But look at numbers less than -5. You have an error. So it wants to know domain. Domain is x. The graph starts at -5, it touches at -5, and then it's greater, so it goes right forever. Starts at -5 and goes right forever, so that is your answer. Domain is x. Okay. Let's see what number 42 is asking. 42, that means we have 31 problems left. Woo-hoo! Good times. Now, 42, we're changing gears. It's still f and g's, but this is an open circle, that means of. I like to write the problem like this. G of f of -26. Composition of functions where you have a function inside of another function, okay? So you gotta start on the inside because remember it's what's on the inside that counts. So you need to do this first. And we're going to do this over on the side. We're going to find the f of negative 26. So use your f equation. And instead of x, you're going to plug in 26. And everywhere there's an x, you're going to put a 26 there. So we have 26 minus 1, which is 25 divided by 9. That's just 25 ninths. Not a nice number. But that's what the f of 26 is. So this, you bring that and put it back in. The f of negative, I'm sorry, it is a negative 26. Let me back up. Negative 26 minus 1, that is nicer. That's negative 27, which reduces to negative 3. So we're going to put negative 3 right here. That is much nicer. Good job. So we're going to find the g of negative 3 now. So you're going to use the rule for g of something. G of something is 3 times something times plus 5. 3 times something plus 5. The something is negative 3. You can type that in the calculator, or you can just use order of operations. Negative 9 plus 5. Negative 4. And that is number 42. Check your answers as you go. Take your time on the test. Now, number 43 is another composition. However, there's no number involved. At the end of this problem, you'll notice it says find the f of g of x. There's no number. So there's going to be x's left in the answer, okay? So I like to write f of g of x like this. F of g of x. Who is on the inside? It's g of x. So let's plug in what g of x is. G of x is 4x minus 1. So instead of g of x, I substitute in what it's equal to, 4x minus 1. Now I'm finding the f of something. So I'm using the rule for f of something. The rule for f of something is 3 times something plus 5. Instead of x, we're putting all of this, 4x minus 1. You're going to distribute and then combine like terms. We have 12x minus 3, bring down the plus 5. Negative 3 plus 5 are like terms. Bring down your 12x, negative 3 plus 5, positive 2. So the f of g of x is 12x plus 2. 12x plus 2. All right, 44. You've been asked to find the g of f of x. Open circle means of. G of f of x. So I'm going to take g of f of x. There's no number here, so there's a letter, so we're going to have variables in our answer. So you start on the inside. Remember, it's what's on the inside that counts. What does f of x equal? Well, f of x is x minus 8 over 7. So we've done on the inside. Now we're going to do the g of something. The rule for g of something is 7 times something plus 8. And instead of x, instead of 7 times x, it's 7 times this stuff, x minus 8 over 7. Now, nice things happen. You have 7 on top, 7 on bottom, so 7 divided by 7 is 1, which is just 1 times x minus 8. Then when you bring down the plus 8, nice stuff happens again. Those cancel, negative 8 plus 8, and you are left with x. Now, this is going to lead me into, later on, I've noticed on your review, there's stuff about inverse functions. Two functions are inverses if you do the g of x, if you do g of f of x and get x, and if you do f of g of x and get x, that's a way to check if two things are inverses or not. So it appears these two might be inverses. You actually would have to do f of g of x to prove that. She didn't ask you to do that here, so we're going to move on. Okay, this one looks more fun. Now, don't be overwhelmed. This is a composition of 3 functions because it says find h of g of f of 21. Here's the good thing. There's a number. So a number means we're going to get a number answer. So before we try to work on this, let's rewrite h of g of f of 21. This is really the h of g of f of 21. H of g of f of 21. Remember, you got to start on the inside because it's what's on the inside that counts. So, we need to find the f of 21. So we're going to come over here and do that first. So the f of 21, everywhere there's an x in this f equation, we're going to put a 21 there. So we have 21 minus 3, that's 18. 18 divided by 3 is 6. So the f of 21 is 6. We're going to put that right back in there. Okay, we got rid of one function. Now we want to find the g of 6. We're working our way inside out. What is the g of 6? Well, we're going to come over here. We're going to do that second. Find the g of 6 using the g equation. So g of 6, everywhere there was an x, we're going to put parentheses and we're going to put 6. You may use your calculator if you need to. This is 5 minus 36, I believe that is negative 31. You're going to plug that inside here where g of 6 used to be. We now have negative 31. Now you're going to find the h of a number, the h of something. You're going to use the h equation. H of something is the absolute value of something minus 2. So the absolute value of something minus 2, and this number is negative 31. So negative 31 minus 2 is negative 33. The absolute value of that, positive 33. Sort of a longer question, but not hard. Just takes time. Okay. I noticed the next sections, or the next problems, 46 through 40, actually 46 through 50, they talk about the inverse and is the inverse a function, maybe, stuff like that. So let's talk about it. On 46, she gives you a set of ordered pairs. There's no other ordered pairs beyond those three. And she says, determine whether the function is invertible. That means, can you find the inverse of it? If it is, find the inverse. So, now, what we want to look here, it's the opposite of to determine. Do you remember back when we said how to determine if a relation is a function? Each x can have only one y. Okay, that was the vertical line test. To tell whether a function is invertible or whether it has an inverse, you got to go backwards. Each y can have only one x. So now each y here is listed once. So yes, it is invertible, and all you're going to do is switch your x's and y's. So you're going to say yes, and then you're going to list the set, and you're going to switch your x and y. That is it. It is that easy. Make sure you use the set notation because that is the entire set of that relation. Set of ordered pairs. Now this little -1 means inverse. Find f to the -1, that means inverse. Find the inverse for the function f. Okay? All the y's occur once, so this does have an inverse, and all you're going to do is flip all the ordered pairs again. So you might want to label it f to the -1, because that stands for inverse. Don't notate. And then you're set, you're just going to switch x's and y's. Switch x's and y's. Switch your x and your y. Close your set notation. Okay, it says use the horizontal line test to determine whether the function is 1-to-1. This is like the vertical line test, but it's horizontal. Wow. So instead of vertical, you're going to draw your line this way. And you're going to drag it from top to bottom. And as long as this graph only touches your horizontal line once, then this function is 1-to-1. If it's 1-to-1, it does have an inverse because each y has only one x. 48 passes the horizontal line test. If you look at 49, that fails the horizontal line test. It is not 1-to-1, so that would be a no on 49. Okay, now on 50, says determine whether or not the function is 1-to-1. Well, first of all, you could use a graphic calculator and graph it. Hopefully you should know that this is a line. It's x to the first. If you graph y equals 8x plus 4, it looks a little something like this, a steep line. Is it going to pass the horizontal line test? Yes. So yes, this function is 1-to-1. Yes, this function has an inverse. All you have to answer is it 1-to-1? Okay. The next three problems want you to find the inverse. This is Kate. She's probably only going to give you one of these on the test. If it's a linear one, I'll be surprised. So how do you find the inverse? When you hear the word inverse, you should sort of think opposite. So what you want to do, you want to switch x and y and solve for y. So we're going to switch x and y, solve for y. So in the original problem, f of x is y. So that's why we are not going to make that just x. This is x. We are now going to make that y. We're switching x and y. Then we're going to solve for y. We're going to minus 6. You're going to divide by 3, divide by 3. And honestly, I'm pretty sure, let me check the answer key. I'm pretty sure she just lets you take the whole side and divide by 3. Let me look. Number 51. Yep, she does. Now, that's not just any y. That is the inverse. So the original function was f of x. You should notate this as f to the negative 1 of x equals x minus 6 over 3. Box it, circle it, there you go. Inverse is easy. Switch x and y, solve for y. Now, it can be a little more complicated if you don't have a nice function. This is still a linear function. Okay? Don't let the fractions scare you, okay? Fractions are easy. So inverse, switch x and y. This used to be y, it's now x. This used to be x, it is now y. And now you're going to solve for y. You're going to add 3. And then to get rid of divide by 4, you're going to multiply by 4. Now, I'm going to guess she's not going to let you get away with just saying a monomial times a binomial. So let's distribute. So that is your new y. That's not just any y, that is the inverse of the original. So don't hate, notate. We have the inverse of f is 4x plus 12. Okay? Pretty simple. 53 is another one. I believe it's a quadratic. Okay, don't let this one confuse you. She's given you a quadratic, x minus 3 squared. That's the parabola's been shifted right through. All this is a domain restriction to help you on your answer. This really is not even relevant to you. You don't care. It's for mathematicians. So inverse, switch your x's and y's. This used to be y, it is now x. This used to be x, it is now y. Solve for y. Now this creates some problems for some people. Do you get rid of the minus 3 of the square first? You get rid of who's farthest first. So to get rid of square, you're going to square root the left, square root the right. Square root and squares cancel. So we have the square root of x. Okay? Make sure she doesn't want the plus or minus. I didn't think she did. Okay? You don't have to do plus or minus here because she's already dealt with this constraint. And then we're going to add 3. So we have the square root of x, and then plus 3 is outside. Because you added 3 here. Added 3 here, but they're not like terms. That is your new y. That is your inverse. Let's notate it as such. F to the negative 1 of x is the square root of x plus 3. Okay. Number 54 wants you to determine whether the function is 1-to-1. This is where you would do the horizontal line test. Well, you don't have a graph, she only gave you the equation. You can graph it on the calculator, or you should know that that's a parabola that's been shifted up 5. Do a little something like that. If you want to graph it on the calculator, you can. Do y'all think that's going to pass the horizontal line test? I don't think so. So nope, fails the test. The horizontal line test, it is not 1-to-1. Okay. Some more inverse stuff. 55. Find f to the negative 1, so find the inverse of 9, and then find the inverse, the f to the negative 1 of f of 5 for the function. Okay, this one always confuses people. Don't let the notation confuse you. First of all, this is f. The inverse of that, let's write that down, would be where you switch all the x's and y's. So the inverse, switch x and y's. So let's do the first one. There's two parts of this problem. Make sure you do both on the test. What is f to the negative 1 of 9? Well, we're going to use the f to the negative 1 function. So this is like x. So when x is 9, what is y on the inverse? Well, when x is 9, the y is negative 9 on the inverse. Okay? This is the f of negative 1 of f. When you take a function and its inverse and you compose them, they cancel each other out. Your answer is just 5. Yes, it is that easy. F and its inverse are opposites. They cancel. Just like when you square something, you square root it, they cancel. You're left with x. These cancel, you're left with 5. Okay. 56. Determine whether the function is invertible. That means, does it have an inverse? If it is, find your inverse. Now, you could graph it and do the horizontal line test. Ain't nobody got time for that. Let's just check to see if since we're doing horizontal line tests, we're going to see if there's y's repeat any more than once. Look right here. Your boy, negative 7, is seeing 2 different y's. This does not have an inverse. So determine whether it has an inverse. No. Or no inverse. It's not invertible. Actually, I guess I should say not invertible. So if it's not invertible, we can't find it. If each y had occurred once, then you would have said yes, and then you just would have switched your x's and your y's. Inverse stuff is not that bad. Okay, now, 57, she gives you two problems like this. There probably will just be one of these on the test. It says decide whether they're inverses of each other. Now, obviously, it's a yes-no question. I personally would like to see work if I was the teacher on this one. So here's how you got to do it. You have to do the f of g of x, and you have to do the g of f of x. Now, if these two are inverses, if f and g are inverses, they would normally cancel, leaving you with x. G and f are inverses, they would cancel each other, leaving you with x. But we want to solve it out algebraically and see if this composition function does leave us with x. So we're going to start on the inside. We're going to start with g of x here. That's x plus 5 over 4. So that's what g of x equals. Now we're going to take the f of stuff. We're going to plug all of that into your f equation where x used to be. So f of stuff is 5 times stuff minus 4. So where there used to be an x, we're putting x plus 5 over 4. Now you're going to notice nothing's canceling here. You're not going to equal x. There's no sense even doing this half. If this one doesn't equal x, it doesn't matter if this one does or not. So the answer here is no. They are not inverses of one another. Okay, now let's look at the second problem like this, 58. Okay, we're going to do the f of g of x, and we're going to do the g of f of x. And if we end up getting an x, and we end up getting an x, then we know that both of them are inverses of one another. So start inside. Remember, it's what's on the inside that counts. G of x is 1/5 x plus 1. We're going to use the f of something equation. The f of something is 5 times something minus 5. Instead of x, you're going to plug in 1/5 x plus 1. Hey, look what happens. Nice stuff happens. You distribute. 1/5 of 5 is going to be 1x. 5 times 1 is going to be 5. You bring down the 5. 5 minus 5 cancels. You are left with x. First half of the problem, good. But g of f of x also has to equal x. So start on the inside. G of 5x minus 5. So in the g equation, everywhere there's an x, I'm going to put parentheses, so 1/5 parentheses plus 1. And I'm going to put all of this stuff, 5x minus 5. You distribute the 1/5, you get 1x minus 1, bring down the plus 1. These cancel. F of g of x and g of fx both equal x, so this is a yes. This is they are inverses of one another. Okay. All right, we've been doing inverses for a minute. We haven't talked about the graphs of inverses yet. Cool little trick. If you have the graph of a function and you think it's the graph of its inverse, those two functions should be symmetrical across the y equals x line. Should be symmetrical across the y equals x line. Now, y'all know the y equals x line, or you should, from pre-cal algebra 2. That's y equals x, that's the parent function linear. Drawn in right here. It says the graph of a function f is given. On the same axis, sketch the graph of its inverse. Now, some people are really artsy and they can visualize this and they're just like, oh, it's going to look like this. Okay, no, I can't do that. So I like to pick ordered pairs on the original function. So like, for example, on the original function, f, this ordered pair is 0, -2. Well, what would that be on the inverse? That'd be -2, 0. So, -2, 0. That's where you would start. Okay? This point right here looks like it's 1, -1. Well, if you switch them, because inverse means you switch x and y, that'd be -1, +1. -1, +1. Okay, this point right here is 2, 2. Hey, guess what? That's the same point. Okay, so it does a little something like that. And if you want to get a little bit more specific, maybe pick another function like, I don't know, like 3, 8. It looks like that's 3, 8. And graph 8, 3. Do the inverse of that. 6, 7, 8. See, my graph is off. Can't graph my hand. Well, something like that. And what you should notice, and it's skewed because of my board, my projector, but on your paper, you should notice that if you were to fold your paper right there, you have a symmetrical shape across the y equals x line. Because the graph and its inverses are symmetrical across the y equals x line. Okay, I would pick ordered pairs and switch them. Pretty easy to do. 60 is the same thing. Okay, guys, I'm not going through that. That point's going to be the same. I would pick this point. -3, 0 becomes 0, -3, 1, 2, 3. This point looks like it's -5, -1. So I would do -1, -5. Okay. This point looks like it's -10, -2. So I would do -2, -10. And you might want to pick a point past this, like, I don't know, 5, 2, and do 2, 5. And so the graph looks a little something. I don't know, my graphs are horrible. Hopefully y'all will do better than me. This should be symmetrical across the y equals x line. Okay, if she grades you on your artistic ability, I hope you're in art club with Miss G, that's all I'm saying. All right. Word problems, yay. Okay, before I get started on this, the whole last page, 61 through 72, deals with inverse variation, direct variation, constant of variation. Okay, let me check, make sure this is recorded. If this hasn't been recorded, this could get ugly. Okay, we're good. We're at 1 hour and 9 minutes. Doing the most. Okay, this is probably the toughest section. I'm going to assume she'll give you probably probably 3 or 4 of these on the real test. All right, sorry. Okay, so let's talk direct variation. You might want to, I don't know if you want to take notes on this, just pay attention. If y varies directly as x, so if something varies directly as something, you could use this equation. Y equals k times x. K is called the constant of variation. Okay, so like in this first example, well, number 61, it says the perimeter P of an equilateral triangle varies directly. So P varies directly as x. So P varies directly as x. Write a formula to express the relationship, use K as constant. That's it, you're done. It is that easy, okay? Let's look at number 2. Okay, you're using the same little phrase every time. Varies directly means it's K on top, X. Now, 62, she jumps and does something different. So let's look at the difference. This is not varies directly. If you see the phrase Y varies inversely as X, or something varies inversely as something, you write it as Y equals K over X. And the way I always remembered it is direct, everything's direct, Y equals K times X. If it's inverse, something's going opposite, so the X, whatever it's inversely as, goes downstairs. So it's Y equals K over X. So in number 62, the height, okay, actually let me underline, height varies inversely as base. So this is your height, varies inversely as base, and it's giving you the letters, and you're done on 62. Okay, pretty easy. All right, let's see what's on 63. John kept track of the time it took him to drive to college from his home and the speed at which he drove. He found that the time t varies inversely as the speed r. Now this is inversely, so it's t equals k over r. Because it's inversely, the r goes in the denominator. K is always in the numerator on this equation. Okay, 64. The surface area of a sphere, which is S varies directly as the square of r. Now this is tricky, not really, but you gotta pay attention. S varies directly, so K, and then the other thing, whatever it's varying directly as goes up here. It's not directly as r, it's directly as the square of r. So you're gonna take r and square it. That is 64. Okay. The area of a triangle varies jointly. Now, we've not done one of these. Jointly just means two things are happening. So area of a triangle, does she even give us variables on this? No, we'll have to make a problem. The area of a triangle varies jointly as what? Sorry. Okay, guys, sorry. All right, the area of a triangle varies jointly. That means two things, as the base and the height. So, area varies jointly. It didn't say anything about inverse, so it's going to be K, and everything's going to go in a direct line, directly. Jointly, it just means there's two of them, as the base and the height. You're multiplying them all. Okay, last one in this section. The force of attraction between an object of fixed mass and a second object of mass m varies directly as m and inversely as the square of the distance d between the two objects. Now that seems complicated, let's just break it down. the force of an object of fixed mass and a second object of mass m. Okay, force varies directly. All this is like prepositional phrases. Force varies directly as what? M. Force, doesn't tell you what letter to use, varies directly, so K times M. So that's direct. And inversely, so we're going to put something in the denominator. Inversely is what? As the square of the distance d between the two objects. So it's not just inversely as d, it's inversely as the square. So force varies directly to M and inversely to the square of d. Okay, we're almost done. $67. Now, they're asking you to do something different here. It says, write a formula expressed by the variations. Y varies directly as x. Y is 15 when x is 3. So y varies directly as x. Y equals k times x. They tell you y is 15. They tell you x is 3. You need to solve for the constant, so divide by 3. Divide by 3. Your constant of variation is k. It never changes. It's a constant for this situation. So then you take your equation, y equals k times x, and instead of k, you plug in what k is. It's the constant of variation. So now we have an equation. If I were to give you an x or a y, you could solve the other one. Okay. The next two, there's another way, there's more than one way to do it. I'm going to try to pick the easiest way. Some teachers might have you find the constant of variation first, then find the missing value. I think it's easier to set up a proportion. So it says if n varies directly as p, and it tells you m when p is this, it wants you to find m when p is whatever, they're giving you 3 out of 4 things. Don't worry about solving for k. Nowhere does it say find the constant. What we're going to do is set up a proportion. If m varies directly as p, we're going to say m is to p as m is to p. This is for direct. Inverse variation is going to be different. The reason why we're doing m over p, because if we were to use k, it's m varies directly as p like that. If you were to solve for k, you would divide by p, divide by p. So the constant of variation is constant for these two, and it's constant for these two. So what we're doing is we're taking the constant, m over p, setting it equal to the constant, m over p. All you got to do is remember is, when they give you 3 out of 4 values, you want to set up a proportion like this. So m is to p over m is to p, as long as it says directly. So we have 48 is to 8 as what? M, we don't know m, when p is 5. You could cross multiply. I think it's a little easier than that. 48 over 8 is 6. Instead of divide by 5, multiply by 5. M must be 30. 5 times 6. Now that's for direct variation. If you have inverse variation, inversely, okay, we're not going to do something over something. You're actually going to multiply. Let me back up. All right, if y varies inversely as x, normally we would write this like this. Y equals k over x, because inverse, you put it downstairs. Now, nowhere does it say find k. It says when y is blank and x is blank, find y when x is whatever. It gives you 3 out of the 4 values. So it's sort of like setting a proportion, but if you were to solve this for k, you would multiply by x, multiply by x. So this is y times x equals k. So instead of setting up y over x equals y over x, we're going to say y times x equals y times x. Now people get this one confused with the last one because they think direct variation, it would be direct. Inverse, they think would be downstairs. But remember, we're not doing the k equation. We're going to use the shortcut method, okay? So for inverse variation, it's y times x equals y times x. So 3 times 1/4 equals whatever, we don't know y, times 1/3. This is 3/4 equals 1/3 y. I would multiply both sides by 3 to get rid of the 1/3. 3 times 3/4 is 9/4. Now, you could have plugged in your y and your x, solve for k, and then you could, that takes too long, just do it this way. Okay, 3 more problems. Write a formula expressed by the variation. Now, we're not taking shortcuts on this. We're not doing a proportion. We're not doing it like this. They want you to write it out with k. But that means you have to find k, the constant of variation, first. So let's do it. So it tells you y varies directly as x. That's y equals k times x, because it's direct variation. They give you y. They give you x. You need to find k. So you're going to divide by 8, divide by 8. Let's see, that's going to be, divide by 4, you get 5, divide by 4, you get 2, we get 5 halves. So now you go back to your equation. Y equals 5 halves times x. We found k, you plug it in, now you have an equation for this relationship. You're going to do the same thing on the next two. 71 wants you to find k because it wants you to write a formula for the expressed variation. This time it's inverse. Y varies inversely as x. It's y equals k over x. You know y. We're trying to find k. They give you x. To get rid of divide by 4, you're going to multiply by 4. 4 times 23, you get 92. That is your k. You're going to come back over here, plug your k in. So this formula right here, y varies inversely as x. We know the constant variation is 92. Okay, last problem. Y varies inversely as x. Again, same thing. So y equals k over x because it's inversely. Y is 8. X is 15. We're going to multiply both sides by 15. $15 times 8, we get 120. That is your k. Plug in your k. Y equals the constant variation over x because it's inverse, and you're done. Okay, so if you've had me for pre-cal, I would think this last page is where you struggle the most because we just barely, I don't even know if we touched on that last year. That's more of an algebra 1 thing. The rest should be easy. So if I was studying, I'd focus on the last page, memorize the formulas and stuff. Guys, if you have any questions, y'all know my cell number is 270-889-7710. You can email me through school email or whatever. Take your time on your test, study, good luck. Don't hate, dominate.